Okay, so we're going to get started with balancing the following chemical reaction. We have iron reacting with sulfuric acid, which gives us some iron sulfates with water and sulfur dioxide. Now, the first thing you should always do using the algebraic method is to letter your molecules. So iron will be A, sulfuric acid will be B, this iron sulfate will be C, this iron sulfate will be D, this water will be E, and this sulfur dioxide will be F, okay? Just a quick disclaimer, I'm not sure if these are both called iron sulfate, I forget, but if we're gonna balance this, let's just go ahead and letter each of them, letter each entry, and then we're gonna go off to the right-hand side and label A, B, C, D, E, F, okay? The next thing we're going to do is take a look at our molecules. We're going to take a look at iron, hydrogen. Sorry, the atoms is what we're looking at. So iron, hydrogen, sulfur, and oxygen. So if you look here within your chemical reaction, you have iron, you have hydrogen, you have sulfur, and you have oxygen, okay? Next thing you're going to do is you're going to take a look at iron, and you're going to examine both sides. So both sides of the reaction. So this is the left side, this is the reactant side, and this is the product side. You're going to see how many times does iron occur on both sides. So iron here occurs once here, it occurs once in C, and twice in D. So how do I write this? This would be written as 1A is equal to 1C plus 2D. And let me explain again how we got that. If you look at your chemical reaction, iron occurs once in A, so it's 1 here, and it occurs once in C on the product side, and then it occurs twice in the product side, so 2D, okay? So what about hydrogen? I'll give you a minute to think about hydrogen, just a little quick second. Look at the left side, look at the reactant side. How many times does it occur on the left side? And look at the right-hand side. How many times does it occur on the right-hand side? Okay, and what you'll find is that hydrogen occurs twice in B, and it occurs twice in E. Okay, so 2B, 2E. Okay, what about sulfur? Sulfur occurs once in B, and it occurs how many times on the other side? It occurs once in C, plus 3 times in D, and once in F. Okay, so I'll show you that real quickly. So if you look here, there's only one sulfur on the reactant side, one sulfur in the C position, 3 sulfurs, because this subscript of a 3, in the D position, and 1 sulfur in the F position. Okay, likewise, you can go ahead and do it for oxygen. So oxygen will have 4B on the reactant side, 4C on the product side, plus 12D in the D position, and 1E plus 2F. Okay, so this is what we call a system of equations. And using this system of equations, we can solve for A, B, C, D, E, and F, okay? So that's what we'd like to do. We'd like to use this system of equations, this right here, and we'd like to solve for it. And when we solve for it, we're able to get our values for A, B, C, D, E, and F, okay? So let me just get rid of this because it's a bit sloppy. So the first step we're going to do, what I like to do, is I like to look at my system of equations, and let's see, what can I do from here? How can I start getting rid of things, or how can I start getting values? And the first thing we're going to do is we're going to declare a variable. We'll declare a variable for B. So the very first step is the following. Let B equal to 1. So immediately I know that B is equal to 1, okay? Now if B is equal to 1, that means then E is equal to 1, right? So if you look here, back here, in this equation, the relationship between 2B and 2E is essentially B is equal to E. So if we let B is equal to 1, and if B is equal to 1, that means then E must be equal to 1, right? So we can write down that E is equal to 1. That's good. So far, we found two values. Now let's move on. Let's go ahead and let's plug in our values for B and E. So if I look at the equation for iron, it's 1A is equal to 1C plus 2D. There's nothing to plug in, so I'll leave it the same. A is equal to C plus 2D. Now if I look at sulfur, sulfur is B, but didn't we say that B was equal to 1? Right here, we said let B equal to 1. So I should plug in that into here. So what this will be then is 1 is equal to C plus 3D plus F. Okay, what about oxygen? Well, this one will be 4 is equal to 4C plus 12D plus 1 plus 2F. Okay, so if you look at this equation, how did I get from here to here? So that's the question. How did I get this to here? What I essentially did was I plugged in E is equal to 1 into this position, and B is equal to 1 in this position. So what we'll get is a 4, and we'll get a 1. But I can simplify this further. I can make it look a lot nicer. 3 is equal to 4C plus 12D plus 2F. Okay, now we're left with 3 equations. So what we have here is still a system of equations, but we only have 3 of them, which is really nice, or somewhat nice, okay? So because this is 3 equations, we're going to try to solve for the other variables, what they're equal to. So it took me a while, I will admit, when I did this problem, because I had to think through the math, I had to think about solving the system of equations, and it may not seem clear at first why I chose to do the following combination, but I would say if you have algebraic skills, go ahead and take some time to look at these 3 equations, this one, and this one, and try and see if you can solve for any of the variables, A, C, D, and F on your own. Otherwise, you can just continue the video. And so what I'm going to do is I'm going to choose the following equations. I'm going to choose the sulfur equation and the oxygen equation, okay? And I'm going to try and solve for F. So my goal, find what F is. And now you may ask yourself, why did I specifically choose F? Why can't I choose to find D? And the reason why is I did this problem earlier. So it was easier to find F in the beginning, and you're not seeing all the work I've done, all the scratch work I've done, but I will say finding F first is very helpful, okay? So that's what we're gonna do. So let's go ahead and grab the sulfur equation. 1 is equal to C plus 3D plus F. And let's look at the oxygen equation, which is 3 is equal to 4C plus 12D plus 2F, okay? Now, if I look at the top equation, I can solve for F if I were to go ahead and multiply by -4. So this is where prior knowledge of working with systems of equations is useful in this chemical, balancing this chemical reaction. You may, if you've taken some math courses, I think some people call this Gaussian elimination. I'm not too advanced in my math background, but what I like to do is I like to, try to get rid of things, substitute in things to solve for my variables. But anyways, I'm talking too much. So what you'll get here is -4 is equal to -4c minus 12d minus 4f, okay? And what you'll get in the next line is the same thing as before. 3 is equal to 4c plus 12d plus 2f. I haven't done much. I only distributed. Now, if I were to add this, I'll get -1 is equal to -2f. Ah, that's beautiful. And the reason why we get this is because this -4c and this positive 4c, they cancel out. Same idea goes here. This cancels out as well. And so what this means then, this means f is equal to 1/2. Beautiful. So if I were to repeat the same procedure, let's go ahead and simplify our equations by plugging in f is equal to 1/2. So I plug in f is equal to 1/2. So my iron, right, will still be A is equal to C plus 2D. I still need to solve for that. I still need to solve for the values of A, C, and D. Sulfur is going to be 1 is equal to C plus 3D plus 1/2. Notice the difference between this sulfur equation. Okay, I'm going to highlight it here. This F, we said F was 1/2. So let's go ahead and plug in that 1/2. And that's exactly what I did. Likewise, for oxygen, we'll get 4 is equal to, I apologize. This should be, sorry, I made a mistake. I know I made a mistake because this should actually be 3. This is 3, and again, how did I get 3? Well, at this point right here, I went ahead and I simplified, right? So I subtracted 1 on both sides, and that afforded me a 3, okay? So I get a 3 is equal to this entire expression. So this is my new equation I should be focused on. 3 is equal to 4c plus 12d plus 2f. But what is 2f, right? What is 2 times 1/2? That is equal to 1, okay? And so this is 4c plus 12d plus 1. All right, so I still have, I have a system of equations again. I like saying this. So if you can, do this on your own, that's great. But I'll keep continuing to solve for the values. Also, I'd like to add this value here. So f is 1/2. That's beautiful. All we need is A, C, and D, okay? So let's go ahead and let's try and do that. And what we're going to do here is we're going to find some expressions. We're just going to simplify it a bit further. So what do I mean by that? What I'm going to do is I'm going to choose the iron expression, or the iron equation. A is equal to C plus 2D. And then I'm going to add that to 1/2 is equal to C plus 3D. You may be wondering, where am I getting that? Where did I get this this equation? This came from the sulfur equation, okay? So what I did here was I took this sulfur equation, this entire expression, and I simplified again, okay? So what you'll get is 1/2 is equal to C plus 3D, okay? And that's exactly what you get here, all right? And so I want to simplify my equations further. So the best way I could go about doing that is by multiplying by -1 here, and let's go ahead and add them together. And so what you'll get if you distribute that -1 is -A, -C, minus 2D is, and then you get 1/2 here, C plus 3D, okay? And what you'll get in the very end is 1/2 minus A is equal to D. Okay, that's the expression that you get. And you might say, that's not really helpful. Well, keep in mind, we're still going to go and continue, right? And this will eventually help us find some values. So we found an expression. So if D is equal to 1/2 minus A, let's plug into the iron equation to get the following, to get that's a bit sloppy, to get an expression for C, okay? So what do I remember? I remember from my iron equation right here that iron is A is equal to C plus 2D. So if iron is A is equal to C plus 2D, and I rewrite this again one more time, A is equal to C plus 2, but I said here that D is equal to 1/2 minus A. So what I find if I plug it in, 1/2 minus A, I'll get that C is equal to 3A minus 1. I have found an expression or an equation for C and an equation for D right here. So what am I going to do? And these equations are in terms in A. So I'm going to compare both equations. I'm going to compare D is equal to negative A plus 1/2. And I'm going to compare C, which is 3A minus 1/2. So I'm going to compare these two equations to one another. Okay, I'm going to compare them. If you notice, you could rewrite this as y1 is equal to negative x plus 1/2. So that looks like like a regular equation for a line, such as y is equal to mx plus b, right? So if we take a look at the equation for C, this would be y2, which is a different line, is equal to 3x minus 1. So let me go ahead and plot that out, and I already did plot it. This line, which has a positive slope, is y2. y2 is equal to 3x minus 1. And notice how it has positive slope, a negative intercept. So positive, and this is a negative intercept, y-intercept specifically. Notice this is a this is a negative slope. This is a positive intercept, and this is going to be my y1. Okay, y1 is equal to negative x plus 1/2. So what if I set them equal to each other and find what a value allows them to be equal to each other? So I find what this intercept is, and I want you to notice this is not the best drawn graph, so it's not directly on the x-axis. Okay, so just keep that in mind. It's just I guess the resolution is not the best. So just keep in mind this is a rough sketch. So if I set this equal to each other, 3a minus 1 is equal to negative a plus 1/2. Okay, then what we'll find is the following, that if I were to move things across, we'll get 4a is equal to 3/2. Divide by 4 is the same thing as saying multiply by the reciprocal, or multiply by 1/4 here. So what we'll get is a is equal to 3/8. Okay, beautiful. That's great. This is good for us. I'm happy. And you know why I'm happy is because now I can fill in this value. This is 3/8. Now, what I'm able to do is I'm able to say what D and C are. So since A is equal to 3/8, then D is equal to negative 3/8 plus 4/8 is equal to 1/8. And you might be saying, oh my gosh, I'm not sure how he did that. Remember, way back here, I said D is equal to 1/2 minus A. So if I were to rewrite this, I'll be more, I'll present it more in a more suggestive way. Remember, D is equal to 1/2 minus A. D is equal to 1/2 minus 3/8. If I plug this in right here, 3/8 for A, for A. Okay, but if I find a common denominator, this would be 4/8 minus 3/8, which is equal to 1/8. And indeed, this is what you get right here, what we said earlier. Okay, so D is equal to 1/8. Beautiful. So let's go ahead and write that down. D is equal to 1/8. Another thing I'd like to point out is that C, right, we want to solve for C. C is 3a minus 1. This is going to be equal to 3 times 3/8 minus 1, which is equal to 9/8 minus 8 over 8, which is equal to 1 over 8. And indeed, D and C are equal, right? We set them equal to each other when we solve for this equation. So that's a good sign that C and D are both 1/8. Beautiful. Now that we've done that, we want to multiply in a way that will give us whole numbers, right? As chemists or as scientists, we normally see chemical reactions with whole numbers. It's sort of like when you're cooking and something calls for 1/8 cup, but you want to scale the recipe. So you multiply by number to give you a whole number or whatever number you want. In this case, I want whole numbers. So to do that, I'll multiply by 8, okay? This will get rid of the denominator. So multiply by 8 all across. You'll get 3, you'll get 8, 1, you'll get 1, you'll get 8, and you'll get 4. So the very final answer, if you stayed this long in the video, what you'll get here is 3, 8, 1, 1, 8, and 4. Okay, we're not done yet. You should always check your work. Did I do this right? Sometimes I'm skeptical. Did I do the math right? You should always check. So here we're gonna check. We're gonna do a check. Check. Is this true? So again, on your left-hand side, right, and your right-hand side, your left-hand side is reactants, and your right-hand side is products, okay? Iron, how many times did we say iron was here? We said it was 3. Okay, what about iron on this side? This one looks like 3 as well. How did I know this was 3? 3 is the coefficient, so there's 3 of them here. 1 iron, and there's 2 irons. Look, there's a subscript 2. Okay, so far I'm in the clear that they both agree with each other. What about hydrogen? Hydrogen, there's 16 here, and hydrogen here is also 16. How did I know? I looked at the subscript 2. There's 8 for the coefficient. 8 times 2 is 16. 2 right here, and there's 8 right here. 8 times 2, there's also 16. What about sulfur? Sulfur, okay, there's 8 of them here. Okay, how many are here? There's 1 sulfur plus 3 sulfur, right? Plus 4 sulfur. So what is that total? This is equal to 8 sulfur, which is a good sign. So this is sulfur is equal to 8. So let me just repeat that because I'm a bit scared. This is 1 sulfur, this is 3 sulfurs, this is 4, this is, wait, did I do that right? What am I doing? Sorry. I think I'm having a moment. What happened? Let's see. There should be 8. So this is 1 sulfur plus 3 sulfur plus 4. Oh, yes. Okay, yes. So there's 8 sulfur. Sorry, I don't know what just happened. The next thing we're going to check is oxygen. Oxygen is 32, right? So 8 times 4 of them, that's 32. There's 4 oxygens here. There's 4 of them here. There's 12 oxygens here. Oh no, I don't want to present it in that way. There's 4 here, plus 12 here, plus 8 here, plus 8 here. 8 plus 8, 16. 16 plus 4 is 20. 20 plus 12 is 32. So indeed, this is correct. That what we'll find is oxygen is 32 with this combination. I hope, please correct me in the comments of the video if you believe this is wrong. But I think this is correct. But I have a disclaimer, really big disclaimer. I did the math in another method. Not another method, I lied. Same exact method. But here I found another combination which I believe is also correct. 4, 10, 2, 1, 10, and 5. Now, if I did this right, I think this is another correct solution. And I'll be honest with you, I don't really know how another solution like this exists. I mean, it baffles me. I mean, if you check this as well, let's just check this. If you stayed this long in the video, great. If you didn't, well, I guess you're missing out. But here on the reactant side, there's 4 of them. There is, so let's make a diagram real quickly. Hydrogen, sulfur, oxygen. There's 20 here, there's 10 here, and there's 40 here. If I look on this side, Fe, H, S, and oxygen, there's also 4 here. There's how many? There's 20 here. How many are here? There's 2 plus 3, 3 plus 5. 2 plus 3 plus 5 is also 10. What about oxygen? There's 8 plus 12 plus 10 plus 10. There's also 40 here as well. So what I believe is that I think you can have multiple solutions. Weird. I don't know. I'll have to talk to someone who's, I guess, very mathematical and ask them, what does this mean? I don't know what this means. I just use the method, right? And so your solution in the end is this balanced reaction. One of the things I want to add as well is you can use a Wolfram Alpha systems of equations calculator. And, I plugged in these 3 equations, which look very similar to back then, and it'll get you the following results, the following relationships. Notice how there's C is equal to 3A minus 1, and D is equal to 1/2 minus A. And I think what's happening, why we're getting multiple solutions, is that maybe A can take on multiple solutions. Maybe, I don't know. I would like to show you real quickly. Let me just, I need to switch screens real quickly. Don't want to show you too much on my laptop. But if I were to switch this, let's stop share, and share the other screen, Desmos. So right now, I hope you're looking at Desmos and nothing else. If you look here at this graph, I've plotted out -x plus 0.5 and 3x minus 1 in the blue. What I think is happening is that you can have a range of A values. I don't know, maybe, I don't know, that exist between this or something. I don't know what's going on, but whatever is the case, we're getting multiple solutions. Let me stop share real quickly. Stop share. And let me share my iPad again. Share screen. Start broadcast. So what we'll get in the end is this one in green and this one in pink. Let me know in the comments what you think. Okay, and if you don't like how I've written it very sloppily, I have it here written very neatly before I did the video. So let me just politely scroll slowly there. Hopefully you can see. Hopefully it's not too zoomed out. There you go. There you go. This looks much nicer. Okay, and this is the disclaimer. I have another solution. Okay, so I hope this helped. Thank you for watching. Okay, now how do I pause this video? Stop.